All right, so I have written out the definition of what radian measure is. The radian measurement of an angle is the number of radii that can be laid out in the subtended arc. And so a subtended arc just means the arc, so the outside of the circle that's separated based on what our angle looks like. Okay, so our angle in radians is always arc length, and we usually call the arc length S divided by the radius r. So this is important. Make sure you remember this. This is the definition of an angle in radians. All right, so note, we know how to measure angles using radians, and we also have talked about measuring angles using degrees. So does that mean they're two different things? They're actually the same, and we can actually convert from degrees to radians and radians back to degrees. So let's talk about how we can do that. So how do we convert degrees to radians and radians to degrees? Well, we're actually just going to think about a circle and think about the complete rotation of a circle. So I'm going to draw a little circle on an XY plane. So here's our circle. All right, so if we start here on the x-axis and go all the way around, what angle is this? That is 360 degrees. So a complete rotation around our circle is 360 degrees. What about the arc? The arc that goes all the way around that circle. We have a name for this. So the distance around the outside of the circle is called the circumference. And the circumference of a circle is given by 2 pi r. So we can actually measure radians now, right? So we have this nice angle, all right? We know that we can talk about the radius of our circle, and we know that our arc length around it is called circumference. So to measure our angle in radians, arc length, which is our circumference, divided by our radius. Circumference is given by 2 pi r, divided by radius, the r's cancel. All right, so therefore, one full rotation is 360 degrees. Also, it's 2 pi radians. So that's what we're going to use to figure out the conversion between radians and degrees. So a full rotation is 360 degrees. That is the same thing as 2 pi radians, as we've just discovered. So my note says, what if we divide both sides by 2? Well, we get 180 degrees is the same as pi radians. And so this tells us 1/2 a rotation around our circle. All right, so from here to here is 180 degrees, also known as pi radians. All right, what if we had divided by 4? So 360 equals 2 pi radians. And we divide both sides by 4. We get that 90 degrees is pi over 2 radians. And this gives us 1/4 a rotation. So just like we were able to label our angles in degrees, so like I did here, 0, 90 degrees, 180, 270, we can do the same with radians, right? So this is also 0. 0, pi over 2, which is 90 degrees, pi, which is the same as 180 degrees, 3 pi over 2, which is the same as 270 degrees, and then 2 pi, which is the same as 360. So here's how our conversion is going to work. So if we're going to convert from degrees to radians, we need to multiply our angle by pi over 180. So we're actually using this as the basis for our rotation. I'm sorry, the basis of our conversion. So we're going to multiply by pi over 180. If we want to go the opposite way to convert from radians to degrees, we need to multiply by 180 over pi. So you do need to remember that we need to use pi and 180, but you don't necessarily have to memorize what goes on top if you think about how we want to cancel things. So for example, number 4 says convert these angles to radians. So 90 degrees, 150 degrees, 1 degree, and negative 135 degrees. And we want to convert to radians. All right, so let's start with 90 degrees. We already know what we should get, pi over 2 radians. All right, so the goal is we don't want degrees anymore, we want radians. So to decide which one to choose, well, we want to choose the thing that will cancel our degrees. So we want to put the 180 degrees on the bottom, the pi on the top. All right, so that way our degrees will cancel. Also, 90 goes into 180 2 times. So this is pi radians up here. Okay, so that means we're left with pi over 2 radians. So we've converted 90 degrees to radians, and it's pi over 2 radians. We can do the same with 150 degrees. Remember, we want to cancel the degrees, so 180 degrees goes on the bottom, pi radians goes on the top. All right, so let's see, we have 150, I think, what goes into both of those? We can do, let's see, we can make this into 5 over 6 pi radians. That's what that simplifies to. All right, so then we have 1 degree. We want to multiply by pi radians over 180 degrees. All right, so 1 times pi is just pi over 180 radians. Nothing should be there. All right, and then one thing to note about these, we want to be exact. If you put pi in your calculator, you're going to get a decimal that will have to be rounded, so we want to leave pi in our answers. Finally, negative 135 degrees, pi radians divided by 180 degrees. That gives us negative 3 over 4 pi radians. All right, so now let's talk about going the opposite direction if we want to convert our radians into degrees. All right, so I'm just going to split this in half. Starting with 5 pi over 6 radians. Sometimes I like to abbreviate and call it rads. All right, now I have to figure out, okay, what do I need to multiply 180 over pi or pi over 180? So again, I want to cancel the radians, so I'm going to put pi radians on the bottom, 180 degrees on the top. So what's going to happen here? Well, my pi will cancel. 6 goes into 180 like 30 times. So 5 times 30, we get 150 degrees. So 5 pi over 6 radians is 150 degrees. All right, so I'll do the rest in the next video.